Hey guys, welcome back to our channel Get Play Soon. In this video, we are going to discuss most common Java interview questions. Whether you are a beginner or an advanced Java developer, if you have an interview with Java in it, then this video is for you. Let's get started. But before that, please like this video, share this video and subscribe to our channel Get Play Soon. Welcome to Get Placed Soon. You will find latest job opportunities, comprehensive placement preparation, and insider tips and tricks. So join us at Get Placed Soon and let's work together to help you land your dream job. So what are you waiting for? Subscribe to Get Placed Soon now. And also, a lot more content is coming on our channel soon, so make sure you subscribe and share it with your friends also. Now, getting started with the easiest question, what is Java? To answer this question, we'll mention the basic of Java with few features. Here it goes. Java is a high-level object-oriented programming language that was developed in the year 1990s. Java is designed to be platform independent, which means Java programs can run on any device or any operating system which has Java Virtual Machine installed. Some of the key features of Java include its memory management system, automatic garbage collection, and strong type checking. So, this is how we answer the question, what is Java? If you don't know the keywords like platform independent, garbage collection, memory management system, don't worry. We'll discuss about the features in our upcoming slides. Moving to our next question, features of Java. When asked by an interviewer what are the features of Java, we can mention top 5 features of Java. Here they are. Number 1, simple. Java programming language is considered the simplest and the easiest to learn and understand. Java syntax is similar to C++. Java has removed many rarely used functions like explicit pointers, operator overloading, etc. Java has automatic garbage collection, which means if there is any object which is not used, then Java will automatically remove the object, making it even more simpler. Therefore, the Java code is simple. Moving on to the next feature of Java, that is object-oriented programming. Java is classified as an object-oriented programming language, which means Java is built with the concepts of objects and classes. Therefore, everything in Java is an object. The third feature of Java is secure. When a Java program is compiled, it produces a bytecode. The bytecode is in non-readable form. Therefore, humans cannot interpret the Java bytecode. Therefore, Java is a secure language. Moving on to the next feature of Java, that is multi-threaded. In Java, multiple threads can be created. Also, the multiple threads do not take individual memory. All the threads together use a shared memory space, and these threads are important for web applications, multimedia applications, etc. Therefore, Java is a multi-threaded. The next feature of Java is platform independent. As we already discussed before, when a Java program is compiled, a bytecode is produced, and the bytecode can be run on any operating system or any system which has JVM installed. And this concept is known as platform independent. Java is a platform independent language. Moving ahead, we'll discuss the three most important concepts of Java: JDK, JRE, and JVM. JDK, as shown in the figure, is known as Java Development Kit. It is a development kit used to develop Java applications, as the name itself suggests. Now, the JDK contains JRE, libraries, development tools. But what is JDK? JDK is used to create and test their applications and also to package and deploy them. The JDK is available in various platforms including Windows, Mac OS, and Linux. Moving on to the next concept, JRE. JRE stands for Java Runtime Environment. It is a software that includes virtual machine, that is JVM, class libraries, and other supporting files. What is the use of JRE? JRE is to execute Java code. Without JRE, a computer cannot execute Java code. JRE is required on any system where you want to execute Java applications or programs. Moving on to the next thing, JVM. As you see in the picture, JVM is inbuilt in both JRE and JDK. Whenever you run a Java program, it is moved into JDK and is moved to JRE and it is moved to JVM. The JVM is in charge of interpreting compiled Java code line by line. So it is in charge of running the Java program line by line. Moving on to our next question, applications of Java. When asked by an interviewer, mention few real world applications of Java. This is how you explain. Social media applications or Android applications. Java is primary language used for developing Android applications. Many popular applications like Uber, Instagram, LinkedIn are built using Java. The scientific applications that we use in our labs like MATLAB, NetBeans, etc. are developed by Java. Enterprise software. Java is often used for developing large scale enterprise software systems like IBM WebSphere, SAP Business Suite, Oracle e-Business Suite, etc. Also, we have frameworks. Java Spring Boot are the very important frameworks of Java which are built using Java. So these are the real world applications of Java. Moving on to our next and very important question, is Java a 100% object oriented programming language? No, Java is not an 100% object oriented programming language. Well, it is designed as an object oriented programming language, but there are few small concepts where it supports non-objects also. For example, in Java, we use data types like int, float, and boolean, which are not objects. Therefore, there are no methods and properties associated with these data types. And one more thing, we have static methods and variables, which are non-object oriented features. Java is a strongly object oriented programming language, but it also have small non-object oriented features as well. Moving ahead, this is a very simple but very common question in basic Java interviews. The difference between C++ and Java. C++ allows two types of programming. One is object oriented programming and procedural programming, whereas Java is designed to be purely object oriented programming. It does not support any other styles of programming. In C++, programmers are responsible for managing memory allocation and deallocation. But in Java, we have a special feature called automatic garbage collection. When an object is not used, Java automatically removes that unused object, and this feature is known as automatic garbage collection in Java. C++ needs to be compiled for each platform separately, but Java is a platform independent language, which means when compiled, Java produces a bytecode, and a bytecode can be run on any platform which has JVM installed. This concept is known as platform independent, whereas in C++, for each platform separately you have to compile. Moving on to the next set of questions. Now that we already know that Java is an object oriented programming language, now let's discuss what is an object in Java, what is a class in Java, the differences between class and object, how to write code, how to create class, create objects from it, and how to access them. So let's get started. A class serves as a blueprint from which new objects can be made. So a class is just a blueprint. Look at the picture below. It's just a blueprint of a bicycle, right? So what is an object? Object is the instance of a class. So objects are created from class. The outcomes of class, like these. Now look at the objects here. There are three types of cycles here. Right, now each object has their unique properties, unique set of values. The colors are different, the size is different. One has basket, the other has different shape of handle. So each object has unique set of properties, but the blueprint is same, and that is class. So this is basic what is class and what is object. Now let's look at the code. Now we have public class person. Now don't look at the constructor and methods and get confused. We'll discuss everything in detail in the upcoming slides. Now only concentrate on class. We have a class name person, and we have two variables, and these variables are called instance variables. In class person we have two instance variables. One is name and the other is age. With this class we also have a constructor, that is with the same class name person, and we have two methods, get name and get age. Constructor and methods, don't you worry about it, we'll discuss in the upcoming slide, but I'll just give you a small idea. Constructor will always be the same name as class name, class person, public person, right? And this constructor sets the values for this instant variables name and age. And we have two methods, get name and get age. So the methods define the behavior and characteristics of the person. Now let's look at the object so that you'll get even more clarity. And if you have any doubts, comment below. Now we are going to create objects for this class person. We have created three objects, person 1, person 2 and person 3. In order to create objects, we have to use the keyword new. You can see for creating each person, I have used the keyword new. New person Ram, new person Sia, new person Shiv, right? And the persons are person 1, person 2 and person 3. Now each person has different name, different age, right? Person 1, person 2 and person 3 are called objects. These three objects have different set of values, like different names and different age. So what is a class? Class person. Objects person 1, person 2, person 3. Values Ram, Sia, Shiv. Age 30, 25, 40. Now how to access these objects? To access this object, we should use a dot operator, and we have to call the method name. We have two methods as discussed earlier, get name and get age. So all we need to do is to call the object and call the method. Person1 dot get name here will give you the name of person 1, that is Ram. Person 2 dot get age will give you the age of second person, that is the age of Sia, that is 25. Person 3 dot get name will give you the name of the third person, Shiv. Now I hope you understand what is class, object, how to access it. Don't worry about constructor and method. We will discuss in the upcoming slides. If you have any doubt, comment below. Now, moving ahead and looking at the difference between class and objects. Right, class is a data type that creates objects, and objects is an instance of class. Objects are created from class. When a class is declared, no memory is allocated. But when an object is created, memory is allocated. And when an object is created, heap memory is allocated. I forgot to mention the word heap here. Please note it down that heap memory is allocated whenever a new object is formed. Only one declaration of class is permitted, but many objects can be created using one class. So far, whatever the concepts we covered, if you have any doubts, make sure you comment below. I'll be more than happy to solve your doubts. So moving forward, we have discussed the concept of class, but we haven't discussed the concepts of constructor and methods, right? So let's dig into it. The upcoming interview questions are based on these topics here. What is a constructor? What is a method? Differences, types, constructor overloading, destructors, etc. But make sure you like this video right now. So what is a constructor? Look at the code snippet here. We have a class person, and below it we have a constructor person, and that constructor has some parameters, it has some this keyword mentioned. So what is basically a constructor? Why do we have to? A constructor is used to construct an object of a class, which means it helps to create an object. The constructor must have same name as the class. So in our class, the class name is person. The name of the constructor is also person. Also, it should not have any return type. You cannot even put void person. So constructor should not have a return type. Okay. But what is the use of constructor? Why are we declaring it? Why are we writing it? So the objective, I mean the purpose of the constructor is to set some initial values for the instance variables of object. In simpler words, we are creating objects from class like person 1, person 2 and person 3. And these objects have instance variables like name and age. To allocate, to initialize the name and age for each object created, we want a constructor. So Ram of 30 age, this data belongs to person 1, and this is achieved by constructor. I hope you understood this concept. If not, make sure to comment below. So this is a constructor. So the purpose of the constructor is to give some initial values for the instance variables of the objects. Moving ahead, what is a method in Java? So let's see what is a method in Java. In Java, method is a block of code that performs a specific task. So it is nothing but a function. Method is nothing but a function. It has some task. It has some work. Whenever you call method, it will come and do the task. Whenever you call the method, it performs the task. And the method is defined inside a class. What is the use of method? The code looks organized. I mean, the task which are writing will be in a separate block. Therefore, it will be organized and it is reusable. Instead of writing the same part of code again and again, you can just call the method, so it is reusable. There is specific way you declare a method in Java. So it basically consists of two parts: method signature and method body. Method body is nothing but the body, the code inside method. Method signature consists of four things: the way you declare it, access level. In our method wish, the access level is public. The return type is void. The name of our method is wish. We do not declare any parameters, but you can also declare parameters. You can also give parameters to methods. So, what is a method? It performs a specific task. Now, what does this method do? Look at the code now. Our method wish is taking the age and increasing it with 1, and then it is printing happy age, and then it is printing the age. Now look at the object created. I've created an object P with the instance variables Sai and the age 30. Right, now I'm calling the method with the help of dot operator, P dot wish. Now what will it print? It will print happy 31. Make sure that you notice that the age we gave is 30, but the method is incrementing the age and then wishing happy 31. So this is method. I hope the concept constructor and method is clear for you. And now let's look at the differences between method and constructor. The name of the constructor should be the name of class. So in our example, person, the class name is person and the constructor name is also person. But the name of the method can be anything. Default constructor is created by compiler. So in your code, if you forgot creating a constructor, you just created a class and left it, then a default constructor is automatically created by compiler. But there is no such concept of default methods that is created by compiler. Okay. Now Constructor should not have a return type. You cannot even mention void, but method must and should have a return type. So these are the basic examples of constructor and method. Now let's see different types of constructors available. Usually we have two types of constructors. One is default constructor and the other is parameterized constructor. What is a default constructor? Look at the code snippet again. As I mentioned in the differences, if you forgot to create a constructor, then automatically compiler will create a constructor, right? And in the code snippet, you can notice that there are no parameters. There are no arguments. No-arg constructor. What is a no-arg constructor? If any constructor has zero arguments, then it is known as no-arg constructor. So a default constructor is a no-arg constructor in Java. Let us see. Java provides a default constructor for a class that does not explicitly define any constructors. The default constructor has no arguments and is called a no-arg constructor. All the instance variables are set to their default values. Even though if I don't write this dot name is equals to empty string, this dot age is equal to 0, automatically they are set to 0, null, false, and so on. Their values are set to the default values. So this is default constructor. Let us see the other type of constructor, that is parameterized constructor, which is a normal one which has parameters. As simple as that. In our example, what are the parameters? Name and age. What is the use of parameters? The normal use of constructor, right? It is used to set initial values for the object's instance variables. Generally, there's a concept called copy constructor. But in Java, we don't have this concept of copy constructors. C++ used to have it. C++ has a default copy constructor. To achieve copy constructor, to achieve that, we have different ways in Java. There is no such concept of copy constructors in Java, but C++ used to have a default copy constructor. But there are several ways we can define copy constructors in Java, and this is an activity for all the viewers. Figure out the ways how to create copy constructors on our own in Java and comment below. Now moving ahead, constructor overloading. If you look at the class here, we have a class person and we have three different constructors available. What is a constructor overloading? It's a concept of creating multiple constructors in same class. In the same class person, we have three person constructors. Okay, what is meant by constructor overloading? If you look at the code snippet, we have a class person, but we have multiple constructors, right? So constructor overloading is a concept of creating multiple constructors with different parameters. What is the use of constructor overloading? It provides flexibility, guys. So it provides flexibility to create objects with different initialization options. So compiler gets a chance to choose whatever constructor it needs based on the parameters we declare. Moving ahead, destructor. Do we have a destructor in Java? No, there is no destructor concept in Java. But let's understand what is destructor. Destructor is an opposite thing of constructor. Constructor help to create objects of class, but destructor destructs the objects. But in Java, as we have this amazing feature, automatic garbage collection, which we have discussed in our previous slides a couple of times, so there is no concept of destructor in Java. Moving on to our next set of questions, which are based on the keywords final, static, this, super. What is final keyword in Java? The final keyword in Java is used to define variables, methods, or classes that cannot be changed or overridden. Now let's see a final variable in Java. Final variables are used to define constants. For example, here we have a variable max value, an integer variable which is assigned with the value 10. Before the variable declaration, as underlined, you can see a final keyword is mentioned. Because of that, you cannot update the max value anytime in the code. Whenever you print the max value, it prints 10. So, final variable in Java stops value change. Moving ahead, we have final method in Java. A final method is a method that cannot be overridden by a subclass. For example, here we have two classes. One is a parent class, my class, and the child class, that is my subclass. The parent class is having a final method print message, and the child class cannot have the same method because final method is a method that cannot be overridden by a subclass. So the subclass cannot have this final method print message. Therefore, final method in Java prevents method overloading. Moving ahead, we have final class in Java. When a final class is declared, it cannot be extended by any other class. Therefore, final class is a class that cannot be subclassed. Final class in Java prevents inheritance. If you are unsure about what it is an inheritance, Stay tuned. In the upcoming slides, we'll decide what is an inheritance. That is it about the final keyword and the variable, method, and class. Moving ahead with the static keyword. A static keyword is used to create class level members that can be accessed without creating an instance of class. It is a non-access modifier. And we can also apply the static keyword with variables, methods, nested classes, etc. Now let's see what is a static variable in Java. A static variable are initialized when the class is loaded into memory and can be accessed using the same name without creating an instance of class. In this example, in the second line, you can see we have a variable count which is declared as static, and we have a constructor for this class, my class, and you can increment the value of count. So this static variable, the count variable, is loaded in memory in only one place. Therefore, static variables are often used to maintain a single value across all instances of the class. There is only one copy of the variable for all instances of the class. So there is only one count, only one place the count is. Moving ahead, we have static method in Java. Static method can be called without creating an instance of class. Static methods are often used to perform utility functions that don't depend on particular instance of the class. In this example, the add method is a static method. Since it's a static method, it can be called using the class name without creating an instance of the class my class. As shown here, int result is equals to my class dot add function. So with the help of dot operator, we're calling it. So what are the advantages and disadvantages of the static method, static keywords, static variables? Static variables make the program memory efficient because they are stored in the class area rather than the heap area. But we have few restrictions. Static methods cannot access non-static data members or invoke non-static methods. The keywords this and super cannot be used within a static context. What are the keywords this and super? Now let's discuss this and super keywords. This keyword. This keyword in Java is a reference variable that refers to the current objects. Very simple. This keyword is used to refer the current object and mainly used to avoid naming conflicts between instance variables and local variables. Now let's look at this. This code defines a class named person with a private instance variable name. The person class has a constructor that takes a string parameter named name. When the person object is created using the constructor, the value of name passed as a parameter is assigned to the instance variable name using the this keyword. This is done to differentiate between the parameter name and the instance variable name which have the same name. Now we are using this keyword to refer to the instance variable name, not the local variable name. So if you're confused, make sure you comment in the comment section below. Please try to understand that instance variable is private and look at the code again and again, you will understand. So what are the uses of this keyword? We have many uses of this keyword. We can refer to the current instance variable. We can call another constructor in the same class to pass the current object as a parameter, to return the current object, to refer to current class instance. So this can be used in many situations like this. What is the super keyword in Java? In Java, the super keyword is used to refer to the parent class of a subclass. It can be used to call the constructor or methods of parent class, access the variables of parent class, override the methods of parent class. So let's see and understand with the help of code. We have a parent class animal and a child class dog that is come from the parent class animal. In this example, the dog class extends the animal class and has its own constructor that takes a name parameter in addition to the species parameter of the parent class. Here you can see as highlighted the super or species statement in the dog constructor calls the constructor of the animal class and passes the species parameter to it. So with the help of super keyword, we can refer to the parent class of a subclass. This is super keyword, as simple as it. So we are done with the keywords. Now let's see few more interview questions based on these keywords. Yes. Main method in Java is static. You always notice in Java, we declare the main method as static. Public static void main. Why? The main method being static allows it to be called without creating an instance of the class, and JVM also recognize as the entry point of the program. So Java main method is declared as static. Now you tell me in the comments below, can a main method in Java be declared final? Let me know in the comments below. Moving ahead, what are the differences between this and super keyword? This keyword refers to the current class object. Super refers to the superclass object. Superclass is nothing but parent class. This keyword access all non-static methods and variables. Super keyword access superclass variables and methods from subclass. Superclass is a parent class and subclass is a child class. So super keyword access parent class variables and methods from child class. With the help of this keyword, we can call other constructor in the same class. With the help of super keyword, we can call superclass constructor from subclass constructor, which means we can call parent constructor from child. Moving ahead, what is static final variable in Java? We know what is static, we know what is final. What is the combination of both? A static belongs to class itself. Final means variable value cannot be changed. So a static final is a combination. A static final variable represents a constant value that is associated with the class rather than with any instance of the class. So this variable will have the two properties, static properties and final properties. Belongs to class and the value cannot be changed. Therefore, when have declared a variable as static final, then the variable becomes a constant. Moving ahead, the next set of questions are based on the famous OOP concepts: abstraction, encapsulation, polymorphism, and inheritance. What is data encapsulation in Java? You can see a capsule here, and the name also suggests encapsulation, capsule, right? As the name suggests, encapsulation is the idea of bundling data and methods together within a single unit, and this single unit acts as a class, right? So, just because it's a class, this unit can be used to create objects. The purpose of data encapsulation is to hide the internal details of object from the outside world and to provide a well-defined interface for interacting with an object. The next question, what is inheritance in Java? Inheritance is a feature that allows a class to inherit properties and behavior from another class. In this code, we have two classes: class animal, which is a parent class; class dog, which is a child class. Class dog extends animal. So this extends keyword which makes the inheritance possible. So class dog extends animal makes the dog receive the properties and behaviors from the animal class. The parent class is also known as superclass. The child class is also known as subclass. Moving on, what are the types of inheritance in Java? We have 5 types of inheritance. Let's see one by one. Single inheritance. Single inheritance allows a subclass to inherit properties and behaviors from a single superclass. In other words, a subclass extends only one superclass. So A is a parent class and B is a child class. B is being inherited from A. B extends A. Moving on, we have multi-level inheritance. Multi-level inheritance is the process of inheriting a derived class from another derived class. In other words, a class can be derived from a derived class. This process can be continued up to any level. So, A is a parent, B is A's child, and C is B's child. So, B extends A, C extends B. This is multi-level inheritance. Moving on, we have hierarchical inheritance. Hierarchical inheritance involves creating multiple subclasses that inherit from the same superclass. This means single class can be a superclass of multiple subclasses. So B extends A, C extends A. This is hierarchical inheritance. Moving on, we have multiple inheritance. Multiple inheritance is not supported by Java directly, but we can achieve multiple inheritance through interfaces. First, understand what is multiple inheritance. As shown in the figure here, multiple inheritance allows a subclass to inherit properties and behaviors from multiple superclasses. So C is inheriting the properties from A and also from B. So C extends A and C extends B. And this is directly not possible. Moving ahead, we have hybrid inheritance. Hybrid inheritance is a combination of two or more types of inheritance like single, multi-level, multiple, right? So hybrid inheritance can be achieved not only through the combination of two or more types of inheritance, but also it can be achieved through a concept called interfaces. With the help of interfaces, we can also achieve multiple inheritance. Yes, in Java, multiple inheritance of classes is not supported, but multiple inheritance of interfaces are allowed. So you can achieve hybrid inheritance in Java by using a combination of inheritance types, including interfaces. Now, what is this interfaces concept? This concept we will cover in the upcoming slides, so please stay tuned. Meanwhile, let's see the next question. What are the limitations of inheritance? Tight coupling. Inheritance can lead to dependencies between the parent and subclass, making it harder to modify code. The second limitation is inflexibility. Inheritance can make it difficult to change the behavior of subclass without affecting the parent class. So the subclass is coming from the parent class. For example, B extends A. So A is parent, B is child. So without affecting A, we cannot change B. So this is little inflexible. Moving ahead, we have fragile base class problem. Changes to the parent class can lead to unexpected behavior or errors in the subclass. For example, we have B extends A. If we change the code in A, in future, wherever B is called or B is performed, then we might face some errors. And this is another limitation of inheritance. Limited reuse. Subclasses can only inherit from one parent class at a time, limiting code reuse. Method overriding. Subclasses can override methods in the parent class, which can lead to unexpected behavior or errors. So these are the limitations of inheritance. Moving ahead, what is polymorphism in Java? This is another root concept. As the name itself suggests, poly means many, morph means form. Polymorphism is the ability of object to take on different forms. We have two types. One is achieved with method overriding and one is achieved with method overloading. And the names are runtime polymorphism and compile time polymorphism. But what is the use of making an object into different forms? What is the use of polymorphism? Let's see. Polymorphism allows for more flexible and modular code by enabling objects to be used in a variety of contexts. It can make the code reusable and it can also make the code maintainable code. So polymorphism is a really important concept. Now let's see the types of polymorphism. Compile time polymorphism, which is achieved with method overloading. What is method overloading? A method overloading occurs when two or more methods in a class have a same name but different parameters, and this allows the same method name to be used for different purposes. When a method is called, the appropriate version is selected based on the type of number of arguments passed, and this is usually decided by the compiler. So, this type of polymorphism, which is achieved by method overloading, is known as compile time polymorphism. Moving ahead, we have runtime polymorphism, which is achieved through method overriding. What is method overriding? A method overriding occurs when a subclass provides a specific implementation of a method that is already provided by its parent class. Which means when a method is called to an object of a subclass, the implementation in the subclass is used instead of the implementation in the parent class, right? The method in the subclass must have the same name, return type, parameter, list as method in the parent class. So both parent class and subclass should have same things. This polymorphism, which is achieved by method overriding, is known as runtime polymorphism. Now let's look at the differences between runtime polymorphism and compile time polymorphism. What is the difference between compile time and runtime polymorphism? In compile time polymorphism, the call is resolved by the compiler, and in runtime polymorphism, the call is not resolved by the compiler. Compile time polymorphism is also known as static binding, early binding, and overloading. Runtime polymorphism is also known as dynamic binding, late binding, and overriding. Compile time polymorphism is achieved by method overloading, and runtime polymorphism is achieved by method overloading. Compile time polymorphism is less flexible as all things execute at compile time. Runtime polymorphism is more flexible as all things execute at runtime. So these are the differences between compile time and runtime polymorphism. Moving on to our next question, what is abstraction in Java? But before that, let me give you an example. A TV remote control allows us to interact with TV without having the knowledge of how the TV works. For example, we can increase the volume, decrease the volume, we can change channels, but we don't know how the change is happening, right? In this example, the TV remote control is an abstraction layer that hides the TV's internal workings and just provides us a simple interface like buttons to change, to modify the volume, etc. Right? So, this concept is called as abstraction. The process of hiding implementation details and showing only the essential features of an object is known as abstraction. Abstraction in Java is achieved through abstract classes interfaces. What are abstract classes and interfaces? Let's see in the upcoming slides. But before that, what is the use of abstraction? Abstraction helps us to reduce complexity and makes code more maintainable by allowing changes to the implementation details without changing the rest of the code. So if you have to update anything in the code, you can change it without changing other things in the code. So it is more maintainable, it is more modular, it helps us to reduce complexity. That's why abstraction is important. Now let's see what is an abstract class in Java. Always remember, abstract classes do not have objects. We cannot create objects from an abstract class. To declare an abstract class, we have to use the keyword abstract. In the first line, you can see we are declaring an abstract class animal. Also below that, we can see a constructor also. Yes, we cannot create objects from an abstract class, but still we can declare a constructor in Java. In few programming languages, constructors for abstract classes is not allowed, but in Java you can declare. But without objects, what is the use of creating constructor? Let me know in the comments below. Other than that, we can create methods and abstract methods also. To declare abstract method, we have to use the keyword abstract again. Remember, abstract method will not have an implementation in abstract class. Moving ahead, what is an interface in Java? An interface is like a blueprint that lets you define a list of methods and variables that a class can use. And the interface in Java will not have any implementation, no code. So what is an interface? It is just a blueprint for the class. So the classes can make use of these interfaces to do some specific task. So what is an interface? An interface is like a blueprint that other classes can use. The interface will have details like methods and variables. Now let's see what are the features of an interface. So one of the key feature of interface is an abstraction which allows us to define common behavior without providing any implementation details. Yes, there is no implementation details in abstraction. The classes that implement an interface must provide their own implementation for the abstract methods defined in the interface, which allows for flexibility and customization while ensuring consistent behavior across classes. The next feature of interface is that it supports multiple inheritance, meaning a class can implement multiple interfaces. This allows a class to inherit behavior from multiple sources, which is not possible with class inheritance alone. We already discussed this concept in the previous slides. Multiple inheritance in Java is not possible, but it is possible with the help of interfaces in Java. Now let's see the differences between abstract class and interface. This is a very common interview question. Abstract class does not support multiple inheritance. Interface supports multiple inheritance. Abstract class can have final, non-final, static, and non-static variables. Interface has only static and final variables. The abstract keyword is used to declare abstract class. The interface keyword is used to declare interface. An abstract class can be extended using keyword extends. An interface can be implemented using keyword implements. A Java abstract class can have class members like private, protected, etc. Members of a Java interface are public by default. Moving on to our next question, how the memory is allocated in Java. Java splits the Java memory into stack and heap memory. The stack memory stores local variables, method, call frames, and primitive data types with short lifetimes. Heap stores objects created with new keyword like instances of class, arrays with longer lifetime and managed by garbage collector. So what is the difference between stack memory and heap memory? Let's look into them deeply. Stack versus heap. JVM throws the java.lang.stack overflow error if the stack size is greater than the limit. To avoid this error, increase the stack size. In heap, Java throws the java.lang.out of memory error if the JVM is unable to create the new native method. The stack memory is done automatically by the compiler. The heap memory is done manually by the programmer. The implementation of stack memory is hard. The implementation of heap memory is easy. Memory allocation is continuous in stack. Memory allocation is in random order in heap. It is thread safe because each thread has its own stack. Whereas heap, it is not thread safe, so properly synchronize of code is required. Moving on to our next question, explain exception handling in Java. Exception handling in Java is a mechanism that allows a programmer to handle runtime errors and exceptional conditions that may occur during execution of a Java program. So, when you execute a Java program, you might face some runtime errors or some exceptional conditions, and these problems are handled by a concept called exceptional handling. When an condition arises, such as a division by zero or an array index out of bound, an exception is thrown, which interrupts the normal flow of execution and transfers control to special block of code known as exception handler. Moving on to our next question, what are the keywords used in exception handling? There are 5 keywords used in exception handling. Fundamentally there are 5 keywords: try, catch, finally, throw, throws. Try is used to define a block of code that may potentially throw an exception. The code within the try block is executed normally until an exception is encountered. Catch. Catch is used to define a block of code that is executed when an exception is thrown within the corresponding try block. It allows the programmer to specify how to handle the exception, such as logging an error message, displaying a user-friendly error message, or taking corrective action. Next, finally. Finally is used to define a block of code that is executed regardless of whether an exception is thrown or not. Yes, whether it is thrown or not, this is a block of code that is executed. It is commonly used to release resources or perform cleanup operations such as closing file handles or network connections that were acquired within the try block. Moving ahead, we have throw. Throw is used to explicitly throw an exception from within a try block. It allows the programmer to manually trigger an exception to be caught and handled by an appropriate catch block. Moving ahead, we have throws. Throws is used in method signature to indicate that the method may throw one or more exceptions. It allows the programmer to specify which exceptions the method can throw so that calling code can handle them appropriately using try catch blocks.